This video is going to teach you how to graph quadratic equations that are in standard form. So go ahead and take some time to write down the title and also the quadratic standard form that's listed over here with y equals ax squared plus bx plus c. So anytime you see an equation written like this is what we call quadratic standard form. Hopefully you remember from before too that making it a quadratic is when the x is squared. So that should look different than any of your linear functions that you've seen before. A quadratic will always be in the shape of a U. Sometimes they can be opening up and sometimes they can also be opening down. And we'll talk in more detail about that later. Some things I want to point out to you is that these U-shaped are what we call parabolas. So if I say the word parabola, that's just a fancy word for U-shaped. And you notice here there's this red line down the center. This is what we call the axis of symmetry. It actually, if you can notice, it reflects this same line just on the other side. So the axis of symmetry is like a reflection line. And then, of course, notice that when the parabola goes through the y-intercept, we call it 0, c. And so you notice that anytime you have a value for the c, that will be the y-intercept, as long as the a is greater than 1. All right, again, copy down these, go ahead and pause your video and copy down the steps, and we'll talk about it on the next slide. All right, our first step was to find the vertex. Again, make sure you are writing down finding the vertex, and then in order to find the vertex, that is, let me go back here. Let me show you what the vertex is. Vertex is just simply either the lowest point, or if this was upside down, like this one, it would just be the highest point of the graph. Okay, so that is called the vertex. Vertex, okay? Also known as the minimum or the maximum. Of course, if this is opening up, the vertex would be considered to be the minimum. If the parabola was opening down, the vertex would be the maximum. Okay, so here we are back to finding the vertex. So you can find the x-coordinate of the vertex by following this simple formula of negative b divided by 2a. Once you have your x-coordinate, you plug it back in to the equation to figure out then what the y would equal. Okay, so let's go ahead and practice that a few times. It's not letting me drop it. Hold on. There we go. Okay, so again, let's go ahead and list off the a value, which is 1, because that's right here. There's a 1 right here. And the b value is 2, and the c value is 5. So again, if I'm following this formula up here, x is equal to negative b, so I'm going to make that a negative 2 over 2 multiplied by 1. So that makes negative 2 over 2, which is just simply negative 1. And again, so I know that my vertex is going to have a negative 1 as its x value. But in order to find the y value, I need to take this negative 1 and plug it into each of the x's and solve. So I'm going to switch colors here. I'm going to do that below here. So we have y equals, and again, that's negative 1 squared plus 2 multiplied by negative 1 plus 5. So negative 1 squared would be giving me a positive 1. This gives me a negative 2 and a plus 5. So, of course, we have 1 minus 2, which is negative 1, and then negative 1 plus 5 gives me back up to 4. Now go ahead and try number 2 and 3 on your own, and then unpause the video for the answers. So here are the answers as follows. Let me click off of that. There you go. Now you can see. So 1, negative 4 should be your vertex for number 2, and 0, 0 should be your vertex for number 3. Okay, so the whole reason why we find the vertex is because that is going to help us with graphing our quadratic. So here's our first example. So go ahead and write example 1 down. Y equals x squared minus 2x plus 3. All right, so again, my first step is to find the vertex. So before I do that, I'm going to list out the a value, which is 1. The b value is negative 2. And the c value is equal to 3. So the vertex is negative b over 2a. So let's go ahead and list that. So I have a negative and a negative. And I've got 2 multiplied by 1. So now I'm at a positive 2 over 2, which just simply equals 1. And now, again, I'm going to take this 1, and I am going to plug it back into the equation to figure out what the y would be. So y equals, we've got 1 squared, 3. All right, so we've got 1 minus 2 plus 3. So 1 minus 2 would give me negative 1, and negative 1 plus 3 gives me a positive 2. Okay, so I've got my two values here and here. So we know our vertex is 1, comma 2. All right, our second step is to make a table of values using our vertex. So I'm going to write x comma y. Sorry, that's not very straight. And if I start with the vertex, a good rule would be to go a couple below the x value and a couple above it. That way you get, both sides of the parabola. So what I mean by that is I'm just going to write a 1 here in the center. I'm going to go a couple below that, so maybe 0 and negative 1. And then I'm going to go a couple above it, 2 and 3, let's say. All right, so again, just like you learned in your last standard, you're going to plug these points into the equation up here and figure out what their y values are. Okay, so over here to the right, you can see some of my work, but all I was doing was plugging the x values in and figuring out what their y value would be then. I hope you noticed that this was my vertex, and check it out. It just mirrored the other side, okay? So when I go over here to plot my points here, all right, oh man, this is kind of a rough graph. Let's see, I'm thinking that this is 0, so this is not going to help me because I'm negative. All right, so let's see. If this is 0, that would have to be negative 1. Oh, let me get my pen first. All right, so we got negative 1. Oh, man, I just keep messing up here. All right, so we've got negative 1 and then up to 6. Let's plot that one. And then 0, 3. And 1, comma 2. And 2, comma 3, and 3, up to 6. So hopefully you see that it just completely mirrored itself. So let's go here. See how good I can do it on this little thing. There we go. Cool. All right, so I've got myself a quadratic. It's a parabola. It's U-shaped. Notice it's opening up. Okay, and of course we have the axis of symmetry, which you can see right down here, down the center. Would make a straight line. Oh, hopefully your straight line is better than my straight line. All right, let's try one more. Notice now the a value is negative. That's going to be very important for you to notice. Okay, I'm going to pause the video and work out a little bit of stuff, but again, my first step is to find the vertex. Okay, so I've worked out the vertex over here. So far, I've just found the x-coordinate. Again, I'm going to plug that 2 back into my original equation to figure out y. Again, please pay close attention to the fact that there's a negative a value here. So when I replace that 2 in here, I have to do 2 squared first, then add on the negative. So it's really y is equal to, again, 2 squared is 4, so it's, and then I keep the negative, so it's negative 4 plus 8 subtract 5. So negative 4 plus 8 gives me a positive 4, and then 4 subtract 5 gives me a negative 1. This is where we see a lot of students make that mistake, so please pay close attention to the fact that the a value is negative. We get to ignore that for right now. But I will show you one in just a second about what if we are plugging in a negative x value. How would that change things? So my next step, of course, is to make a table of values. So I'm going to go ahead and do that again. And again, we're going to place the vertex, which we said was 2, negative 1, sort of in the center here. And then, of course, I'm going to go a couple below it and a couple above it. So I might go 3, 4, 1, and 0, and let's go. I want to go ahead and show you a negative 1 just to show you what it will do in the equation. Now, some teachers will just have you do one side of the parabola, and then you would just mirror it over to the other side. But I typically like to do a little bit on each side so that I can make sure that I get all my points. All right, so when I take this -1 and I plug it into the original, again, I have y is equal to a negative value up here, and then I'm putting a -1 in here as well. So that's -1 squared. So I have two negatives listed here, plus 4 multiplied by -1 minus 5. So again, I've got -1 squared, which makes a positive, but then since I have a negative on the outside, it goes back to negative. So it's -1. This would be -4, and then subtract 5. All right, so we've got a bunch of negatives, and again, that would equal -10. All right, so -10 right here. Okay, I'm going to pause the video and figure out the rest. Hopefully you are pausing the video and figuring out the rest too. All right, so a couple things I want to point out to you. I put in green when I did the +1. Notice how it still, came out -1 as well. All right, and again, looking at these values, they just mirror each other. So if I were to add on 5 here, then I know, since it was -5, I know then it would have to be a -10. They just mirror each other. Also, please notice this C value always tells you where it's going to cross the y-axis at. And again, it's listed here in our table of values too. Okay, so please be aware of that. All right, so let's go ahead and start off by graphing. Again, I'm going to pause it so that I don't take up so much of your time. And again, the quadratic should look like this. Notice it mirrors each other. Here's the vertex. We would call this the maximum point vertex, and it's the maximum point. Okay, we've got our y-intercept here at -5. This is our axis of symmetry right down the center. So axis of symmetry, they reflect each other on either side. All right, next up is a couple things about it. So I've been kind of mentioning these throughout the video. But again, just so you know, you might want to write all these down. The graph that you see, if you look at the A value, if it's greater than 0, then the graph will open up. If it's less than 0, meaning it's a negative number, it will be opening down. And then if you look at the A value as well, if the absolute value of A is greater than 1, it's going to be narrower. If it's less than 1, it's actually going to create a wider parabola. Now, that does make sense. Narrow just means that the number's higher, so the graph is going to reach higher points a lot faster. Where like a less than 1, like a fraction, it will take longer for the graph to continue on. Again, I've been pointing out the axis of symmetry. Again, that's just this line right here, the red line that breaks it in half. And then, of course, we've talked about the vertex already, and we've already talked about the y-intercept too. All right, something else I'd like to point out to you is that a quadratic can have solutions. The solutions just means the x-intercepts of the graph. Of course, quadratics can end up with 2 because it can go through, both times. Or here, the vertex actually lands on the x-intercept, so this is what we call one solution. And then the last one, it could actually be above the x-intercept, or it could be also opening down and below the x-axis as well, and therefore it would have no solutions. So if we ever mention in class about solutions, this is what that means, is the x-intercept. Where is it crossing through the x-axis at? All right, you guys, here is your exit slip. Please go ahead and graph both of these. I would like for you to list out, make sure that you're listing out the vertex. And if you could please also tell me if it's a minimum or a maximum. Okay, enjoy. Thanks, guys.